and welcome to PHYS1110 Everyday Physics. I'm Liz Angstman and I'm your lecturer for this course. I'm also the first year director here in the School of Physics. So I really hope that by doing this course you're going to start looking at the world differently. When you see something going on, I hope you can think to yourself, actually, I know how that works. I can explain all the physics which is going on behind it. So in order to get to that point, you are going to need some maths. Maths is a really useful tool for physics. So there are no formal university prerequisite subjects for this, but you do need to have a good understanding of algebra, some trigonometry, especially around right angle triangles, and some geometry. So this is a non-calculus course. Any calculus which is presented is entirely optional, but you do need to be fairly comfortable with using some mathematics. So each week in this course we're going to look at a different topic. So the topics will be related to everyday things. So for example, in the first topic we're going to be considering how a streetlight works. So in order to understand that, we're going to be learning a bit about electric current, electric power, electric circuits, and we'll also be looking at the photoelectric effect, which was really exciting because it was some of the first evidence of quantum mechanics. So each week we'll have a different one of these topics. In these topics, you'll be presented with videos which will cover the theory behind how the thing works and the physics. There'll be some worked examples in these lectures so that you can see how to solve problems about these things. And then there'll be some demonstrations to show you that what I'm telling you really does happen. So there will also be suggestions of little activities that you can do at home. It's a good idea to take this course a bit skeptically and test stuff out for yourself to make sure that I'm actually telling you the truth. Now, in order to do well in physics, in fact, in order to do well in almost anything at university, lots of research has shown that you need to practice answering questions. So after each set of videoed lectures, there'll also be approximately 10 tutorial problems for you to try. I highly recommend that you try these yourself. If you then get stuck, there are videoed solutions which explain how to solve each of these problems. Now, to do an online course, you do need to be fairly self-motivated. Nobody's actually going to check whether you've done the tutorial problems or not. However, if you don't do the tutorial problems, you're probably going to struggle with the online tests that come up. Now, physics is an experimental science. Everything we're doing is based on experiments and observations. So throughout this course, you are going to have 4 experiments that you will need to complete at home. Now, these experiments have been designed to use common household equipment, which hopefully you have easy access to at home. If you don't, it is possible to borrow these from the School of Physics on a 24-hour loan. It's really important that you return them within the 24 hours so that other students can borrow them if they need to as well. So the details about how to do this are on the Moodle site. So throughout this course, you're going to have 4 experiments to do. The first one is going to be measuring the specific heat of water, which you will do with a kettle and a measuring jug. Ideally, you'd also have a thermometer, but that is optional. So what you'll do is you'll conduct the experiment at home, you'll write it up, and you'll submit it through Turnitin. Now, you will need to take a selfie of yourself with the equipment to include in the report in order to get it marked. You are allowed to do the experiment with one other person who's also doing the course. If you do that, you need to acknowledge them in your report, and the selfie should include the 2 of you with the equipment. So the assessment in this course, you've got those 4 experiments, which in total are worth 30% of your mark. You've also got fortnightly tests. So you'll have half an hour each fortnight to do a test. So there'll be 3 one-hour blocks set aside, and within those 1-hour blocks you can spend half an hour on the test. So have a look at where those times are, and I recommend that you put them into your calendar now so that you're definitely free at one of the times that the test is available. So these tests are to make sure that you can actually solve physics problems. There is no final exam for this subject. Now, probably the most exciting bit of the assessment is at the end of the course, you're going to produce a report about an experiment that you will do to test the physics behind something of interest to you. Now, this will go much better if you do choose something which you actually find interesting. So, for example, if you're really into tennis, you could consider looking at why do they refrigerate tennis balls before serious tennis matches. You could look at different bounce heights and see how they correlate to temperature. Is a colder ball more bouncy or less bouncy? If you're a keen musician, you could consider looking at a phenomenon such as beats. So beats occur when you play two frequencies which are similar but slightly different. When you play them together, you get a beating noise where the sound level goes loud, then soft, loud, then soft. You could consider investigating this. Now, with your report, there's a few steps to it. First of all, you're going to submit a proposal to your tutor who can give you some feedback. Hopefully it'll be, that's a great idea, go ahead. But if they do have some concerns, they'll help you get on the right track so that you have a good experiment to do. Then you'll need to submit a draft of your final report. So you will submit this and it will be peer reviewed by 5 of your peers. So you will also be peer reviewing 5 of these reports. And you'll actually be marked on the quality of the feedback that you give to your peers. So hopefully this will lead to you seeing quite a number of interesting reports and also getting some very useful feedback on your own report, which will allow you to improve your own report before submitting it to your tutor for final marking. So the peer review process and proposal is worth 10% of your mark, and then your final report is worth 20% of your mark for this course. Now, the work expectations for this course are quite high. It does have a physics code, it's PHYS1110. So I know some of you have elected to do it as a general education subject, but that's your choice. With physics courses, there is a significant workload. So PHYS1110 covers the same physics as our face-to-face course Fundamentals of Physics. Fundamentals of Physics has 8 contact hours each week, and we encourage students to spend a similar amount of time solving problems and making sure that they understand the lecture notes at home. So this course would have similar work expectations to that course. So even though it's online, it does have a fairly high work expectation. So if you don't feel like you're able to commit enough time to this course, I would recommend dropping this course now and choosing something else. If you're wanting to do a general education course, then probably select one with a general education code. That being said, there is no final exam in this course, so by the end of week 10, your final assessment is due and then you're completely free of this course for the exam period. With this course, we have had some issues with academic integrity in the past, so we do keep a very careful eye out for these. In semester 2, 2018, a large number of students contract cheated in this course, which meant that they paid somebody else to do the experiments and submit their reports and do some of the online quizzes. We found this, and quite a number of these students were suspended or expelled from the university. So it is really important that if you do this course, you make sure that you're academically honest. You need to do the work yourself, and if you do get help from a partner with the investigation, you need to acknowledge that and make sure that you both contribute to your written report. The textbook for this course is just a recommended book, it's not compulsory. It is Fundamentals of Physics by Cutnell and Johnson. The library do have an ebook subscription to this textbook, so you can download chunks of it for free. This is really useful if you want extra questions to practice. The end of chapter questions in this book are quite good, and so you can use those for extra practice. So I really hope that you enjoy this course and that it does get you thinking about the world in a slightly different way.